Hello, and welcome to our topic today, which is abstraction and standardization for event-driven integrations. This is part of the EDA Summit 2021, which we're honored and privileged to be a part of. Thank you so much for joining us from wherever you may be joining us from. And let's get right into it. So we're looking forward to sharing with you our perspective on how to design an effective event-driven architecture. And we hope you'll gain some insights that perhaps you haven't thought about before. My name is Shane Fisher. I'm here with my colleague, Derek Weber. Both of us are from Slalom, which is a modern consulting firm focused on strategy, technology, and business transformation. Derek and I are both from Slalom's systems integration practice and have many years of integration consulting under our belts. So let's get started. So what we'll be covering in this presentation are the challenges in enterprise event management, the benefits of governance over event structure, optimal channel organization, abstraction framework and mechanisms, challenges and trade-offs of these approaches, and then at the end we'll do a review and wrap up of what we just covered. So just to set the stage, companies typically pursue an event-driven strategy for a couple of different reasons. So perhaps they're supporting an IoT rollout and expect large volumes of event streams. Alternatively, a company might recognize that their current batch-driven strategy is no longer keeping pace with their business and their customers' expectations. So when realizing an event-driven architecture, which is to say, to build that out, to actually put that into place, often the emphasis is on establishing the messaging infrastructure, designing for asynchrony, which is different, right, than what you may be used to, and retrofitting existing batch or request reply style integrations. So our main contention is that as part of an event-driven design, you really should give special consideration in two main areas here. One is loose coupling from a data perspective. And by that, what we mean to say is the proper use of canonical models to abstract away system details. And two, establishing a message classification scheme and topology that is both dynamic and self-describing. So we contend that a well-designed messaging infrastructure is a cornerstone for enabling that snap-in architecture that can keep pace with your business, whether you're conducting continuous acquisitions or your business is constantly adding new things to their portfolio from a business application standpoint. So with the emergence of SaaS-based applications, your business is perhaps going shopping, right, and adding new business applications to the portfolio. And so having that snap-in architecture enables you to respond to those business demands in a much faster, much more predictable manner. So our challenge with this, just to set this stage, is that native and inherited legacy event message formats are notoriously difficult to integrate. So if you think of SAP BAPIs, for instance, in their native format, those can be really difficult to integrate with. And as a result, this results in less reuse of assets and logic due to lack of understanding or even fit for their particular use case. And the result of this is that system integrations become more complicated and difficult to maintain in the long term as a result. And as one would expect, the magnitude of that problem will just continue to grow as new event data sources are added over time. Now you see the background image that's on this slide. This is actually a real architecture. This actually happened at a particular client site. And it was the result of what we call accidental architecture or unplanned architecture. And so enabling an effective event-driven strategy is at least one hedge against building an architecture like this.
Shane, I have a question. Where do you even start to survey the event landscape in an architecture such as that?
That's a great question. So often it comes down to business prioritization. So what are the things that are first and foremost on the business's mind in terms of top priorities to build out this architecture for? So a classic example would be incorporating a brand new ERP system. So that is top of mind for the business. Therefore, everything that sort of goes into or out of that ERP are ripe for sort of refactoring or re-architecture. And so that's where we kind of focus our emphasis maybe in that scenario. And what happens is you build this architecture over time, and as more and more functionality sort of moves out of the legacy realm and onto this new architecture, the old sort of point-to-point architecture sort of dies on the vine, if you will. Great question. So before we get into our recommendations, we'd like to define some baseline terms just to aid in our understanding of the designs that we're proposing here. So at the top, we have canonical model. I think most technologists, particularly in the event-driven space, probably understand what a canonical model is, so we won't spend too much time here, but just think of it as a system-agnostic representation of events or structured messages that you define within a given enterprise or within a given domain in the enterprise. A super topic is a broad event topic that's defined by a category of activity. So the example here would be sales events. So if you have a super topic, that is all sales events. A subtopic is kind of a finer grained event topic that includes or will inherit a specific subset of events from the super topic. So the example here would be not just sales events, but sales events out of the North America office. An exploded topic is a fine-grained topic that represents an individual event concern. So sales events from a main office as opposed to sales events across all offices. And then finally, republication, when we talk about this, what we mean is the process of pushing abstracted events back into the event bus for consumption by the ultimate downstream consumers. Okay, so the next 4 slides, we're going to kind of walk you through a reference architecture around how we think about this in practice, how we think about sort of this message topology and this event-driven architecture. So a framework that conforms to sort of this canonical model that we've been talking about really ensures that all of your event messages are intended for integration consumption, or they're simple to adapt, or in some cases, maybe automatically compatible with certain systems. So your ultimate event consumers, what we think of as subscribers, so you see these on the far right side, are adapted to a discoverable or predictable message structure and data formatting standard for the enterprise. So we're going to talk a little bit more about what this adaptation looks like in just a little bit, but for right now, just understand that this framework really supports 4 main phases, if you will, of an event lifecycle. So the first phase is the combination phase or the combine phase. Phase 2 is mapping transformation. Phase 3 is republication. And then phase 4 is that consumer adaptation that we just referred to. So in the combine phase, which is what you see here, we have native event messages from event producers. So in this example, we're using manufacturing messages. So you see factories that are on the left side here, or an ERP, for example. Those native messages are routed onto a primary information channel. That's a broad category of activity. And that's what we call sort of the super topic. So in this example, we're funneling all these manufacturing events into this manufacturing events native super topic channel. Okay. In the transformation phase, so these events that were published to the native super topic are now pulled out and they're transformed to conform to this canonical model that we talked about. And that makes them sort of enterprise in scope and adaptable or subscribable for all your subscribing systems. And just one more note on that is this layer that we refer to in terms of mapping and transformation, that's most typically provided by either an iPaaS or a middleware. That's a very classic sort of architectural component that provides that capability. Okay, in the republish phase, so this is phase 3 out of 4, once we have that sort of canonical message format, then we're able to publish that onto the canonical super topic. or finer grain subtopics. And we'll get into a little bit more about kind of how that works and what the differences are between those. Derek's going to cover that in just a little bit. In this fourth and final phase, this is where we're really focused on how the subscribing systems are ingesting this data, how they're able to ingest the messages that they're getting off of these topics. And we have two main use cases that we're sort of representing here. So, if you look at, kind of the red and yellow systems, in those categories, we're actually having to adapt that canonical event format to the subscribing system's native format. So in those cases, those are systems that may not be capable of consuming sort of a canonical format-based message. Classic examples of this that you see are sort of legacy systems, like legacy ERPs, or mainframes, just systems that are older and just don't sort of have that capability to do any sort of mapping or transformation. And again, you see sort of the iPaaS layer coming into play here that is, again, providing that capability to do mapping and transformation. In the sort of, in the better case, the one that's highlighted in green, you may have smarter systems that are actually able to ingest the canonical message directly. So that's sort of an example of how this would work.
Shane, follow up on that. What's a quick, simple example of direct consumption?
Great question. So there's two main kind of examples that sort of fulfill that direct consumption model that I can think of off the top of my head. One would be, a system that's highly capable, like Salesforce is the classic example. That's kind of my go-to. Highly capable, code enabled, you can write custom code, you can write custom Apex, sort of ingest the canonical format, do some transformation of your own right within the application. But then there's this other case, which is API driven. So perhaps you're building native sort of APIs that sit in front of all these systems that can actually consume that canonical format directly and respond to that canonical message directly. So in that case, you've got the flexibility to actually consume the native format. Great question. Okay. That does it for sort of the message lifecycle. I'd now like to turn it over to my colleague, Derek, and he's going to walk us through topic green and design considerations.
All right, so I hope we've presented a convincing case of why an event canonical model for the enterprise is beneficial. And now we're going to discuss corollary to that, which is a canonical model for topic design. So we talked a lot about finer grain subtopics before. And what do we mean by that? That is, again, that's a canonical modeled topic, but it's composed and defined based on critical attributes for the event. They can be implemented in two ways. One is a fully qualified topic name, and the other is what we refer to as exploded subtopics. And I'll get into the details in a moment. So a fully qualified topic name corresponds to an event attribute path or hierarchy. So a good example of this would be system followed by location, followed by process or department, and so on. So you're essentially taking the defining attributes of the event and flattening that out so that you can connect and subscribe to any segment of that. And let's move on to the next slide. Okay, so here's an example. You'll see the exploded topics below. So in that case, that is a specific grain, and that's where you would break those into separate topics. For direct subscription, the hierarchical fully qualified subtopic that you see on the right, again, that's that flattened topic structure. That is most well suited to wildcard subscriptions where it's a virtual topic, where the topic name is an attribute. instead of a physical destination. And that allows for dynamic consumption based on any fragment of that topic name. Again, exploded topics are very granular in nature. And then sort of a third option that's more traditional in some ways would be a filtered subscription. And in this example, you see that there's a filter on the main sales events topic. The trade-off with that, though, is that those event attributes must be assigned to the message as properties to support that filtering. So it requires more work, and it's not as transparent or flexible as a more dynamic or more fine-grained subscription would be.
So Derek, quick question for you. Can you explain kind of the difference between a filtered subscription and a wildcard subscription?
Sure. Again, so a filtered subscription is a subset of that, again, of that superset in the topic, but it's going to be filtering on event properties. And for that to be accessible, you must actually set custom properties on those events when they're published. With a wildcard subscription, it's much easier. Again, it's not a physical destination. And so then it's much easier to subscribe based on any pattern match within that. So it's very flexible, very easy to expand that model. And it doesn't have the same level of overhead as a filtered subscription would.
Got it. Thank you.
Okay, so now we're going to discuss some challenges and trade-offs with this approach. So forward compatibility is very important. So while none of us may have a crystal ball, we can project based on the system architecture and integration landscape that exists today and what's planned, and infer from that how it's going to grow over time and how this architecture is going to be extended accordingly. But it's important that you put in the time to get it right. And so you want it to be comprehensive, forward-looking, and easy to adapt. Anytime significant changes are made, once you have dependencies on this, there's likely to be significant knock-on effects or ripple effects to work through those dependencies and potentially refactor accordingly. So the more time put in up front to get it right, the better. And then governance is especially important. Governance is always important, but with this model, you want to have very well delineated information channels, clear patterns, and it should not be possible to consume events in an unintentional manner. When that happens, you can have several significant consequences, one of which would be an event storm, and that would be unexpected redundant processing of events. And even in the case of idempotent consumer processes, in the best case, that's still very inefficient. In the worst case, it could have much more serious consequences, impacting data integrity and other things. So those are two things to keep in mind, and they are easily negotiable with proper planning.
So Derek, another question for you. So the notion of an event storm sounds pretty scary. So do the challenges of this architecture outweigh the benefits of this type of design or layout?
Yes, absolutely. While there is more overhead on the producer side to publish those events into the various topics, both the super topics, the broad super topics that exist, and the narrow subtopics, that specificity that it affords you it supports the broadest number of use cases, both for the event streaming use cases where you want to ingest everything with like fire hose approach, and then those very targeted use cases where you're only consuming a very narrow sliver of those events. And in that sense, it's the best fit on the consumer side. And again, as we've already covered with the event canonical model itself, it's the easiest to adapt as well. So then you have easy adaptation, both on the event message structure and the topic structure.
Great, thank you.
Okay, so here again, you see the complete reference architecture. And we have examples of every facet of this architecture included here, including the transformation. So just to walk through it one more time, we're starting with native events from any possible source. We're going to funnel those based on activity categories that make sense for your organization. And then we're going to transform those to that canonical model. And again, you could have a canonical model that slightly differs based on those broad activity categories. You could have one that's manufacturing specific. You could have one that's finance specific, or you may find that there's a model that fits the entire organization. And that's great if you can do that. So, but it's entirely up to you, and it's very flexible. It will fit whatever your needs are. And then once those events are transformed in that canonical event structure, then we're publishing, again, we're republishing for that broad consumption, and then also for one or more of those tailored subtopics for that fine-grained consumption. And then as needed, we're doing that additional transformation to adapt to those ultimate consumers. And in some cases, there may be nothing required except for the core app development to build that ingestion of the event in the application itself. So there you have it. To wrap up everything we covered, to recap the benefits of the canonical event message and topic model, we have increased information accessibility across the enterprise, reduced technical debt by establishing that snap-in architecture. Increased development velocity is expected for client applications due to that self-describing nature of the infrastructure and the event structure. Broad compatibility for data analytics or any event streaming use cases. And then there's also the loose coupling of data between the systems, and that maximized flexibility you have both broad and narrow consumption of events. We also touched on how middleware is a key enabler of the event transformation and orchestration, and how fine-grained topics enable the most efficient targeted processing of events, and also the importance of a comprehensive, forward-looking, ideally future-proof architecture.
Well, great. Thanks so much for joining us. That concludes our presentation. We're hoping you've gained some valuable insights in terms of how you design a well-functioning event-driven architecture. Please feel free to reach out to myself or Derek at the emails below. Thank you so much and have a great day.